Moving averages smooth the price data to form a trend-following indicator. They do not predict price direction, but rather define the current direction with a lag. Moving averages lag because they are based on past prices. Despite this lag, moving averages help smooth price action and filter out the noise. There are three very popular moving averages used, which are your simple moving average, SMA, exponential moving average, EMA, and the weighted moving average. These moving averages can be used to identify the direction of the trend or define potential support and resistance levels. Here below is a chart with both an SMA and an EMA on it. Simple moving average calculation. The simple moving average is perhaps one of the oldest and most widely used by investors. The simple moving average is formed by computing the average price of a security over a specific number of periods. This is, you add the price over a given period, then dividing the sum by the given number of that period. Most moving averages are based on closing prices. So for example, a 15-day simple moving average would add together the closing prices for the last 15 days. Then you divide that number by 15. We can then classify the periods into long-term, intermediate, and short-term. Short-term ranges from 5 to 25 days, intermediate ranges from 25 to 100 days, and long-term from 100 to 250 days. Short-term moving averages react to current markets faster than the long-term. They are more sensitive because you are calculating using more recent data. As its name implies, a moving average is an average that moves. Old data is dropped as new data comes available. This causes the average to move along the time scale. Below is an example of a 5-day moving average evolving over 3 days. The first day of the moving average simply covers the last 5 days. The second day of the moving average drops the first data point and adds the new data point. The third day of the moving average continues by dropping the first data point, which is 12, and adding the new data point, which is 17. In the example above, prices gradually increase from 11 to 17 over a total of 7 days. Notice that the moving average also rises from 13 to 15 over a 3-day calculation period. Also notice that each moving average value is just below the last price. So for example, the moving average for day 1 equals 13 and the last price is 15. Prices the prior 4 days were lower and this causes the moving average to lag. Now for the second, which is the exponential moving average calculation. Exponential moving averages reduce the lag by applying more weight to recent prices. The weighting applied to the most recent price depends on the number of periods in the moving average. EMAs differ from simple moving averages in that a given day's EMA calculation depends on the EMA calculations for all the days prior to that day. You need far more than 10 days of data to calculate a reasonably accurate 10-day EMA. There are 3 steps to calculating an exponential moving average. First, calculate the simple moving average for the initial EMA value. An exponential moving average has to start somewhere, so a simple moving average is used as the previous period's EMA in the first calculation. Second, calculate the weighting multiplier. Third, calculate the exponential moving average for each day between the initial EMA value and today, using the price, the multiplier, and the previous period's EMA value. The formula below is for a 10-day EMA. Weighted moving average. Weighted moving average is calculated in the same manner as a simple moving average, but uses values that are linearly weighted to ensure that the most recent rates have a greater impact on the average. This means that the oldest rate included in the calculation receives a weighting of 1, the next oldest value receives a weighting of 2, and the next oldest value receives a weighting of 3, all the way up to the most recent rate.